Hi everyone. Here's a quick video. I always say quick, but they're never that quick. About scientific notation because the further you go into chemistry and eventually physics, the more of this you're going to see. You deal with a lot of numbers that are either large, bigger than one, or small, smaller than one. When I say large and small, that's what I really mean in terms of size. And some of them end up being really, really big. So you end up writing a lot of zeros out unless you use something like scientific notation. Powers of 10 notation, it's sometimes called. Same thing with really little numbers like 0.0000071. You don't want to have to keep writing all of these zeros out. It's easier to keep track of all the zeros with powers of 10. So before I actually get into writing numbers in scientific notation, what I want to talk about real briefly is the fact that you can express powers of 10 in terms of exponents. So, this might seem a little redundant, but the number 10 is 1 times 10, but a way to write that shorthand is 10 to the first power, 10 one time. The number 100 is, of course, 1 times 10 times 10, but shorthand way is 10 to the second power. 1,000 can be expressed as 10 to the third power. 10,000, that would be multiplying 10 by itself 4 times, 10 to the fourth power. 100,000 would be 10 multiplied by itself 5 times, 10 to the fifth power. So just following the pattern, 1 million would have to be 1 times 10 6 times, or 10 to the sixth power. This would just keep on going and going and going as the numbers got larger. So 10 million would be 10 to the seventh power. 100 million would be 10 to the eighth power, so on and so forth. When you're dealing with little numbers that are smaller than 1, this is 1/10 in words, but it's 1 divided by 10, or 1 divided by 10 to the first power. Now, a shorthand way to write 1 divided by 10 to the first power is to write 10 to the negative first power. That's literally what the -1 means, 1 divided by 10 to the 1. This is 1/100th. So it's 1 divided by 100. Remember, 100 is 10 to the second, so it's 1 divided by 100, 10 to the second. Shorthand way, 10 to the -2 power. It's a pretty easy pattern to pick up on. This is 1/1000th. So it's 1 divided by 1,000. That would be 10 to the third power. So 10 to the negative third power. This is 1/10,000th. So it's 1 divided by 10,000. That's 1 divided by 10 to the fourth power, or 10 to the negative fourth power. One last one here. This is 100,000th. So it's 1 divided by 100,000, which is 10 to the fifth power. So that's 10 to the negative fifth power. Now this would be 1/1,000,000th. So it would be 1 divided by 1,000,000. Remember, 1,000,000 is 10 to the sixth power, so it's 1 divided by 10 to the sixth. Shorthand way to write that is 10 to the -6th, so on and so forth. It's a pretty easy pattern to pick up on. Excuse me. Well, if you can keep this stuff straight, then the rest is pretty easy as well. And I'm going to show you some shortcuts, so pay attention here. Maybe even scratch down my examples. It's always better for your understanding to write things as you're going along. Pause this video whenever you need to. So if I want to write the number 54,000, this is a large number, bigger than 1. Here's a way I could think about this. 54,000. That's equivalent to writing this. Now, if you don't believe me, you can get your beloved calculator out. 5.4 times 10,000 would give you 54,000. Well, if you think back, we have a way to write 10,000. 10,000, shorthand is 10 to the fourth power. So a way to write 54,000 is to write that, or 5.4 times 10 to the fourth power. This is called scientific notation. This is called ordinary notation. Okay. Do another one. The number 760,000. Well, that is equivalent to 7.6 times 100,000. Once again, if you don't believe me, use your beloved calculator. We have a way to write 100,000 though. 100,000, that's 10 multiplied by itself 5 times, a 1 followed by 5 zeros. So that's 10 to the 5th power. So the scientific notation way to write this would be 7.6 times 10 to the 5th power. That's scientific notation. Another one, 2,310,000. Well, another way to write that would be 2.31 times a million. And we know another way to write a million, it's 10 multiplied by itself 6 times, so 10 to the 6th power. So this would be the scientific notation, and that's the ordinary notation. Now notice something here. Whenever I write a number in scientific notation from ordinary notation, I'm preserving the correct number of significant digits. 54,000 had 2 significant digits. These zeros were not significant because there was no decimal point in the number. Once again here, this number, these are not significant. These are just placeholder zeros. 2 significant digits. There were 2 sig digs here. There's 2 sig digs in the scientific notation version. There were 3 significant digits there. There are 3 significant digits in the scientific notation version. So watch the sig digs. They have to be the same in both versions of the number. Now there is a shortcut. Before I get to this last ugly one, there is a shortcut. If you don't want to think about this middle step, it's kind of a pain. Here's what you can do. Even though there's no decimal point written in this number, it's kind of assumed to be right here. Well, think about this. How many times would I have to move the decimal before I got to a number between 1 and 10? So in this case, I'd have to move it 1, 2, 3, 4 times. So to skip straight to here, I could just write 5.4, and I had to move the decimal 1, 2, 3, 4 times 10 to the 4th power. That's the shortcut. So this exponent can be thought of as how many times you have to move the decimal to get to a number between 1 and 10. Let's use it here. The decimal's not written, but it's kind of assumed to be there. So 1, 2, 3, 4, 5. So the scientific notation version is 7.6 times 10 to the 5th power. Had to move the decimal 5 times. 2,310,000. Here's how many times I got to move the decimal. 1, 2, 3, 4, 5, 6. If I move it 6 times, it'll make the number between 1 and 10. So the number is 2.31 times 10 to the 6th power. It's a nice shortcut. Kind of skips over this whole thing in the middle. So let's use the shortcut here because I really don't feel like doing the thing in the middle. So how many times would I have to move the decimal to get to a number between 1 and 10? So 3 times, 6 times, 9 times, 12, 15, 18, 21, 22, 23. 6.02 times 10 to the 23rd power. Okay? Now you might think, never use a number that big. This is actually one of the more famous numbers in chemistry. So once you take a chemistry class, you're going to learn a lot about that. The shortcut is good, you guys. Just remember, the exponent, the power of 10, it's how many times you have to move the decimal to get to a number between 1 and 10. Now you can kind of do this in reverse as well. So what if you've got a number in scientific notation and you need to express it in ordinary notation for some reason? So we've got 2.3 times 10 to the 7th. Let's use our shortcut. Here's my 2 and my 3. The decimal's right here. I got to move the decimal 7 times. Now this is a large number. I know it's a large number because it's got a positive power of 10. This in reality is 2.3 times 10 million. So a shorthand or a shortcut way of doing this is, here's the 2 and the 3. That's where my decimal is. 1, 2, 3, 4, 5, 6, 7. So that's where the decimal would go. And I got to fill in with placeholder zeros. So the answer is 23 million. Okay? 23 million. 4.33 times 10 to the 9th. So here's my 4, my 3, and my 3. Here's where the decimal is. I know I got to move it 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Got to fill in with zeros, placeholder zeros. Put in some commas here. So that would be 4,330,000,000. That's what that number is. It's a nice shortcut. It's pretty easy to use. Here's a number that's not quite as large. 9.2 times 10 to the 4th. In reality, this is saying 9.2 times 10, 10,000. Here's the shortcut. There's your 9 and your 2. 1, 2, 3, 4 times of moving the decimal. Backfill with placeholders. 92,000 is the number. This last one, believe it or not, this is the mass of the Earth in kilograms. So once again, it's an actual number you're going to end up using in physics. But you would not want to write out, 598000000. So typically it's written this way. But just to show you, hey, you can even write a number absurdly large like this in ordinary notation. 598. Here's where the decimal is. I got to move it 24 times. So 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Ooh, that's a big number. So backfill with placeholders. And you can put some commas in. Now, I don't know exactly how to pronounce that number. Maybe you're better than me and you can figure it out. But it's a big number. Now, you can do all this same stuff with small numbers as well. So small numbers, less than 1. So remember, whenever you're dealing with small numbers, you're going to have negative powers of 10 because it's 1 over a power of 10. So the shortcut way to do this, I'm just going to kind of skip right to the shortcut. We have to move the decimal point until we get to a number between 1 and 10. So a way to write this in scientific notation, shortcut way anyhow, is there. If I put the decimal here between the 4 and the 3, it's 4.3 times 10 to the 1, 2, 3, 4, 5. But this is a small number, negative 5th power. So this would be the scientific notation version. Here's the ordinary notation version. Now in reality, what we're doing here is 4.3 times 10 to the negative 5th. That is 4.3 times 1 over 10 to the 5th. In other words, 4.3 times 1 over 100,000. Okay, That's kind of the middle step that doing the shortcut avoids. How would you express this one in scientific notation? How many times do you have to move the decimal to get to a number between 1 and 10? 1, 2, 3, 4, 5. 2 is between 1 and 10. 2 times 10 to the, I had to move it 5 times, negative fifth. Guys, when you're dealing with small numbers less than 1, you're always dealing with negative exponents, negative powers of 10. This one, 1, 2, 3 moves. 1.8 times 10 to the negative third power. That's the scientific notation version. The smaller the numbers get, the more useful and time-saving scientific notation really is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8.9 times 10 to the negative 10th power. This is much, much easier to write than that. And you can do in reverse. If you have small numbers that are already in scientific notation, you can put them into ordinary notation. Just remember, this is how many times the decimal point has to get moved. Now these are small numbers. It's a negative exponent, negative power of 10. So that means I got to move the decimal point to the left to make it into a small number. If I were to move it to the right, it would make the number larger. And we wouldn't want that because this is a small number. So 1.7 times 10 to the negative third. Here's my 1, here's my 7. 1, 2, 3. 3 decimal moves. So there's my decimal. Let me fill in with some placeholder zeros here. So I had to move it 3 times. There's the decimal. That's where it began. That's where it got moved to. I just backfilled with placeholder zeros. 0.0017. Once again, notice 2 significant digits in this number, 2 significant digits in the ordinary notation version. You can't change the number of significant digits. 8.8 times 10 to the negative fourth. Here's my 2 8s. There's where the decimal starts. I have to move it 4 times. 1, 2, 3, 4. Placeholder zeros, fill them in. There you go. Nine 9.2 times 10 to the negative fourth. Here's my 9. Here's my 2. 1, 2, 3, 4 moves. Backfill with placeholders. There you go. 2 significant digits here, 2 significant digits here. And likewise, I got 1.06. Now this number has 3 significant digits in it. That 0 is significant because it's sandwiched between 2 non-zero digits. So here's where the decimal begins, and I have to move it 10 times. And I know this is going to end up being a little number, less than 1, because of this negative exponent. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. There's the ordinary notation version of that scientific notation number. So just to kind of sum things up here, you guys. Whenever you see positive powers of 10, that indicates that you're dealing with large numbers. They're going to be bigger than 1. Whenever you see negative powers of 10, that indicates you're going to be dealing with numbers smaller than 1. To turn an ordinary notation number into scientific notation, the shortcut is think about how many times you have to move the decimal. In some cases it's an imaginary decimal, but still, how many times you have to move that decimal until you get to a number between 1 and 10. 1, 2, 3, 4 moves would do it here, so it's 5.4 times 10 to the fourth. Positive exponent because this was a big number, bigger than 1. The opposite kind of process would work here. If you have a number that's in scientific notation, you want to turn it into ordinary notation. That's still how many times the decimal has to get moved. This is a positive power of 10, so it's going to be a big number, bigger than 1. You got to move the decimal 7 times. Backfill with placeholder zeros. Small numbers. If you see a number that's less than 1, that's going to tell you end up with a negative exponent. Still, however many times you have to move the decimal to get to a number between 1 and 10, that ends up being that negative exponent. And then, like we just got done talking about, this is the opposite of that process. So I see a negative third here. That tells me this is a small number, smaller than 1. I'm going to have to move the decimal 3 times. That's where it began. 1, 2, 3. Fill in with placeholders.